Good day, everyone. Welcome to RICHFIELD Hybrid Learning. My name is Silas Topereso and I'm your lecturer for Mathematics 512 module. Today we're going to look at our topic 3, which is tangents and limits. On the learning objectives of this module, upon completion, you will be able to demonstrate the ability to calculate the gradient and the slope of any equation of a tangent or a function at any given or desired point. You will also develop the skills to verify the value of the limit of a function at a point using definition of limit. In addition to that, you also have knowledge of understanding on how to differentiate between continuous function and discontinuous function. And you have the knowledge of all the different types of discontinuous functions such as joint function, jump function, removable discontinued function, and non-removable discontinued function. Let's now look at the definition of tangent. A tangent to a curve is a straight line that touches the curve at a single point but does not intersect it at that point. When a line crosses a curve twice, is called a second line, but a tangent, it doesn't cross a curve, it only touches but without crossing the line, this curve. The problem of finding the tangent line to a curve and the problem of finding velocity of object both involve finding the same type of limit. So we're going to use a limit function or process in order to find what to call the tangent line or slope of a tangent line. The special type of limit is called a derivative, and we will see that it can be interpreted as a rate of change in any of the science or engineering or computer science field. Below is an example of a tangent line to a graph. If you check on my first graph here, I have got a curve that is in blue and the tangent line is in red that is touching that curve at a single point. And that point you've got a coordinate which is A and FA, where FA is the value of Y and A is the value of X corresponding to this point. So this is the tangent line that doesn't cross the curve but only touches it without crossing it. If you check on my second graph, I have also a curve that is in blue and I have a line that it touches that curve at a single point, and this curve also is a tangent line. This line also is a tangent line. So using the definition of limits, you should be able to calculate the slope of a tangent line as well as calculating the equation of a tangent line. Here is another example of a graph that is got a tangent line. If you check here, we have got a graph of fx which is in blue, and this graph we've got a line in red that crosses this curve at 2 points. So any line that crosses a curve at 2 points, we call it a second line. But we have got another line that is also in green here. If you check this line in green, it only touches our curve, but it doesn't cross it. So any line that touches a curve but doesn't cross it, we call it a tangent line. So this line in green is our tangent line to this curve of fx. Let's look at tangent formulas. The equation of a tangent is in the form of a linear equation, which is y is equal to mx plus b, because a tangent line is simply a straight line that is in the form of linear equation. So to calculate a slope of a tangent line, you need to use the limit formula that is saying limit of x approaching an a, because you'll be calculating a slope at a certain value of x in your function of a curve. So this fx represents the function of your curve. Then you simply say fx minus fa, where a is a certain point of the value of x where you're calculating the slope. So you divide by x minus a. So when you solve this limit, what you're going to get when you substitute the value of x, you're going to get a slope. Or sometimes we call this expression as a dy over dx, which is the derivative. Or we can say a slope is simply a change in y over change in x. So to calculate the equation of a tangent line, since it's in the form of a linear equation, you simply also use a formula that is saying y minus y1 is equal to m, which is a slope, times x minus x1 in order to calculate the equation of your tangent line. On this example, which says find the slope and equation of a tangent to the curve with the equation below, which is fx is equal to x squared at x equals to 1. The question requires us to find the slope and the equation of a tangent that touches this curve at x equals to 1. So the first thing that we have to do, we have to find the tangent slope. So to find the tangent slope, we use the limit formula that is saying limit where x approaches a of fx minus fa divided by x over a. So in place of fx, we're going to put the expression of fx, which is x squared. That's how we have x squared here. Then in place of fa, a is equals to 1 because we have got x equals to 1 at that point. So we replace fa with f1. F1, when you solve on the right side of, in place of x, we put 1. We're going to solve our expression of f1 and get the value as 1. So we put 1 in place of fa. Then now on the denominator we have x minus a. In place of a we put also 1. Then we are going to have x minus 1, and in place of x approaches a, we have x approaches 1. So this is the expression that we end up having. But now we can't solve this limit by direct substitution of the value of 1 in place of x, because we'll end up getting a denominator of 0. So we need to find the factors of our numerator, which is the factors of x squared minus 1, which are going to be x minus 1 and x plus 1. So if you see, x minus 1 on numerator is end up cancelling each other with the denominator of x minus 1, and we are going to have a x plus 1 as our result. So we end up having limit of x plus 1 where x approaches 1. And this now, if you substitute the value of 1 in place of x, it's going to give us 1 plus 1, and we get a slope of 2. Then after getting a slope of 2, we need to find the value of y when x is equal to 1. So we substitute the value of x in our expression of fx, and then we solve for y, and we're going to get our coordinate as 1, 1. Now we have got one of our coordinate, and we have got a slope. The next thing that we have to do, we have to find the equation of our tangent line. We know that our tangent line is in the form of y is equal to mx plus b, because it's a linear equation. So we already have a slope. So substitute this slope in our equation of y is equal to mx plus b, and we're going to have y is equal to 2x plus b. But now we don't have the value of b. We need to solve for b. To solve for b, we need to substitute the value of 1 of y and the value of 1 of x into the equation of y is equal to 2x plus b. Then we're going to have 1 is equal to 2 times 1 plus b, and then we make b the subject formula. This 2 minus 1, when 2 jumps to the other side of equal sign, is going to be negative. That's how we have 1 minus 2 is equal to b. Then our value for b is going to be minus 1. So now we can substitute this value of b, which our y-intercept, into the equation of y is equal to mx plus b. Our slope of m, we know we got 2, and then our y-intercept is minus 1. So this is how we find the equation of our tangent line, which is in the form of linear equation. Now we come to limits of functions. A limit tells us the value that a function approaches, the value of y that a function approaches as that function, the inputs get closer or move closer and closer to a certain number or certain value of x. We said that the limit of fx is equal to L as x approaches a, which is the value of x. And we write this in the form of limit fx is equal to L where x approaches a. So a limit L of fx, which is L, a value of y, exists only if the approach from both sides of x-axis towards that certain value of xa is the same. So when you solve with the approach from both sides and get the same limit or the same value of y, which is L, then you can say that the limit of that function exists. Here we have got an example for solving the limit. So we have got an equation that is saying estimate the value of the following limit, which is limit x squared plus 4x minus 12 over x squared minus 2x, where x approaches 2. So when we're solving the limit of this expression, or we want to find whether the limit exists for this expression, we need to find the value of the limit of the limit of y when we're approaching from both sides of this value of x, which is 2. So we need to solve when we are coming from the positive side, from the values above 2 towards 2, and coming from the values below 2 towards 2. And if those two approaches are giving us the same limit of a value of y, then we can actually say the limit of this expression exists. So in solving this expression, we are not going to substitute the value of 2 directly into the expression because we are going to get a 0 as a denominator. So we need to find the factors of our numerator and denominator so that we eliminate some of the common factors that appear on the numerator and denominator for us to find the solution of this limit. So here are the solution that we have here. We started by solving from the positive side of approaching 2 from the positive side. So when you start substituting the value of x, which is 2.5, we get the value of y as 3.4. When you substitute 2.1, we get 3.85. When you substitute 2.01, we get 3.9. So we can see that as you move the value of x closer and closer and closer to 2, approaching 2, the value of y is also moving closer and closer, approaching 4, which becomes the limit. So if we move from the other side, which is below 2, from the negative, here we started with 1,5. Then when we substitute 1,5, we're getting 5.0. Then when we substitute 1,9, we're getting 4.159. When you substitute 1.99, we're getting 4.0. So you can see now as we move again closer and closer towards 2, the value of y is also moving closer and closer towards 4. So which is similar to the approach from the other side, which is the positive side, the right side. So the approach from the positive side and the approach from the left side are giving us the same limit of the value of y, which is 4. So we can say this expression has got a limit of 4. Here's the graph of our solution for the limit of x squared plus 4x minus 12 divided by x squared minus 2x as x approaches 2. As you can see here, this is x where x approaching 2 from both sides. So our fx, as x approaches 2 from the left side, our fx is approaching this value of what? Of 4, which is the value of y. So the limit of this expression is get closer to 2, the value of y, which is our limit, is 4. As you approach the value of 2 of x approaching 2 from the positive side or right side, our value of our function fx is approaching the limit of 4 again. So as you see, when the function moves, as it moves from the right side towards 2, our value of y is 4. So 4 becomes the limit of this function because the approach from both sides is giving us the same limit of 4. Now we're using the calculation to find the limit of the same function, which is x squared plus 4x minus 12 divided by x squared minus 2x, where x approaches 2. In this instance, we cannot solve this by direct substitution of the value of x as 2 because our denominator is going to be 0, which is against our mathematical rules. So we need to find the factors of our denominator, which is the factors of x squared minus 2x, which is going to be x into x minus 2, and the factors of our numerator, which are going to be x minus 2 and x plus 6 as our factors. Now, as you can see, we have got the common factors that are in our numerator and denominator that we're going to cancel each other. Then we are going to left with the expression that says limit of x plus 6 divided by x, where x approaches 2. And in this case now, we can safely substitute the value of x as 2 in our expression, and we're going to have 2 plus 6 divided by 2, which gives us 8 divided by 2, and then reduced to 4 as our limit of this function. Some limits can be solved by direct substitution. For example, below, that is saying solve limit 2x squared minus 3x plus 4, where x approaching 5. When we are solving this limit, we simply directly substitute 5 in place of x. So when we're substituting 5 here, we're going to get 2 is equals to 2 times 5 to the power 2 minus 3 times 5 plus 4, which gives us 50 minus 15 plus 4, which reduces to 39 as our limit. So the second question or second example said solve limit x cubed plus 2x squared minus 1 divided by 5 minus 3x. So when you check on this expression that you've got division, if we directly substitute minus 2 on the denominator, is not giving us 0. So another thing, if you check on a denominator and your numerator, we don't have the common factors that we're going to divide or going to divide by each other. So here you can directly substitute your value of minus 2 into your expression. When you direct substitute here, you are going to get minus 2 cubed plus 2 minus 2 squared minus 1 on the numerator, divided by 5 minus 3 times minus 2. And it's going to give us minus 8 plus 8 minus 1. And then on the denominator gives us 5 plus 6, which reduces to minus 1 over 11 as our limit for this expression. Some limits can be solved by factorization and cancelling the common factors that exist in both numerator and denominator. Not all limits can be evaluated by direct substitution of the value of x. For example, below saying solve limit of x squared minus 1 divided by x minus 1 where x approaches 1. If we try to solve this limit by direct substitution and substitute the value of x as 1, we're going to get 1 squared minus 1 divided by 1 minus 1, which gives us 1 minus 1 on numerator, divided by 1 minus 1, which equates to the solution of our expression as a limit of 0 over 0, which is undefined. The right way of finding the limit of this expression, since if you direct substitute, you are going to get a denominator of 0. We need to find the factors of our numerator. We need to factorize our numerator and then factorize our denominator. Then if we factorize our numerator, we're going to get factors of x minus 1 and x plus 1 on a numerator. So when you check on our numerator and denominator with the common factor, which is x minus 1 and x minus 1. So we can cancel x minus 1 on numerator, which cancels each other with the x minus 1 on the denominator. And you are going to left with the limit of x plus 1 as x approaches 1. Then now we can directly substitute our value of x, which is 1, into the expression. And we're going to get 1 plus 1, which equates to 2. So our correct solution or limit of this expression is 2. Let's look at how to solve some of the limits using the multiplication with its conjugates. If we have got the square root on the numerator, we can multiply that square root with its conjugate. For example, we have the question that says solve the limit of square root of x squared plus 9 minus 3 divided by x squared where x approaches 0. In this instance, we cannot do direct substitution, because if we do direct substitution of 0 in place of x, we're going to get 0 as our denominator, which is against our mathematical rules. And we cannot also factorize our denominator and numerator, since we don't have any common factors. So the only solution that we have to approach is by using the multiplication with the conjugate. So the conjugate of this expression is simply the conjugate of the numerator, which is the square root of x squared plus 9 plus 3, which is the opposite of minus. So we multiply each and every term, both the numerator and the denominator, with that conjugate. So when we multiply that one, we're going to get the limit of square root of x squared plus 9 to the power 2 minus 3 to the power 2 divided by x squared times the square root of x squared plus 9 plus 3, where x approaches 0. When we solve this expression, it reduced to x squared plus 9 minus 9 on the numerator, and on the denominator we retain the same expression that we have, which is x squared times the square root of x squared plus 9 plus 3. Then now x squared plus 9 minus 9, it reduced to x squared as our numerator. Then now if you check on the numerator, we've got x squared, and denominator we've got x squared. So x squared we can cancel the x squared on numerator and denominator, and we're going to left with the limit of 1 divided by root 2 x squared plus 9 plus 3, where x approaches 0. And now we can do direct substitution. In place of x, we substitute with 0, and we're going to have 1 divided by square root of 0 squared plus 9 plus 0, which gives us 1 divided by square root of 9 plus 3. Square root of 9 is 3. So we're going to have 1 divided by 3 plus 3, which reduces to 1 over 6 as our limit. Limit and continuity. The limit of a function fx exists if and only if one-sided limits of function are equal. In other words, simply means the limit of fx exists if the approach of fx towards a certain value, or a particular value of x, or from the left side, is equal to the approach of fx towards that particular value of x from the right side. When these two approaches are giving us the same value of y, which is the limit, then you can say the limit of that function exists. For example, we have got the question that says solve limit of x, absolute value of x squared minus 4 divided by x minus 2 if limits exist. So in this enumerator with the lines, which is the square lines, they simply represent absolute value, which means this value takes both positive and negative values. So when you approach the solution of this question, you need to solve the approach from the positive side. We'll say limit of the same expression, which is x squared minus 4 divided by x minus 2, approaching from the positive side, which is 2 to the power plus, means approaching from the positive side, and the approach from the negative side, where 2 to the power negative, it simply means the approach x approaching 2 from the left side or from the negative side. So the numerator absolute value when approaching from the negative side, the absolute value is going to be a negative times x squared minus 4 divided by x minus 2. So we have to solve these two limits from different approaching from different sides. If their limits are the same, then the limits of this solution we say it exists. Here now we're going to solve our expression from the right hand side, which is the limit of x squared minus 4 divided by x minus 2, where x approaches 2 from the positive side. So if you do direct substitution of the value of x equals to 2, our denominator is going to be 0, which is against our mathematical rules. So we need to find the factors of our numerator here. If you factorize our numerator, we're going to get the factors of x minus 2 and x plus 2 divided by x minus 2. So now x minus 2 and x minus 2 on the denominator can cancel each other. Then we're going to left with the expression limit x plus 2, where x approaches a 2 from the positive. Then now we can do direct substitution, and we are going to get 2 plus 2 is equal to 4 as our limit of approaching from the right hand side. And we'll do the same with the limit approaching from the left hand side. If we check on this expression, we also have to find the factors of our numerator. When we find the factors of our numerator, which is x squared minus 4, we're going to get minus x minus 2, x plus 2. And now x minus 2 and x minus 2 are cancelling each other, on which are common factors of our numerator and denominator. When they cancel each other, we're going to left with an expression of limit is equals to minus x, because is minus x is going to multiply on x and then become negative, and this negative multiply on 2 and become negative. So we're going to have minus x minus 2, where x approaches 2. So now when we do direct substitution, we're going to get minus 3 minus 2, which gives us minus 4. Since now the right hand side limit, which is equals to 4, is not equal to the left hand side limit, which is equal to minus 4, we can conclude that the limit of our expression of absolute value of x squared minus 4 divided by x minus 2, where x approaches 2, does not exist. A function is continuous at any point of C if it meets three properties of function. In this instance, we can say a function is continuous at a point C if fc is defined, or if limit of fx where x approaches C exists, and if limit fx where x approaches C is equal to fc. For example, we have the question that is saying, is the fx x cubed minus 4x squared minus x plus 10 continuous at x equals to 1? So to check if this function is continuous, it has to meet all the three properties. So to check for the first properties, we need to substitute the value of x is equals to 1 in our function to solve for f1. When you substitute, you are going to get 1 cubed minus 4 times 1 squared minus 1 plus 10, which gives us 1 minus 4 minus 1 plus 10, which is 6. So to check for the second, so f1, we can say that f1 is defined. So we check for the limit of our function where x approaches 1 if it exists. So we now do direct substitution of x equals to 1, since this one doesn't have any division. So when you substitute 1, you are going to get 1 cubed minus 4, 1 squared minus 1 plus 10 is equals to 6. So we can say that the limit exists. No, so we check for the third property, which is the limit of a function should be equal to the f1 of our function. So when we check the limit of our function where x approaches 1 is equal to 6, which is equal to f1. So since the limit of our function where x approaches 1 is equal to 6 is equal to the f1, which is also equal to 6. We can conclude that this function fx is equal to x cubed minus 4x squared minus x plus 10 is continuous at a point of x is equal to 1. On this graph of our function, you can see that the function is continuous at x is equal to 1. X is equal to 1, our y is going to be 6. So if you check here the graph, our graph is continuous. Discontinuous function. A function that is not continuous is said to be discontinuous function. We call them discontinuous functions. So we have got different types of discontinuous functions. So we have got to call jump discontinuity, removable discontinuity, as well as infinite discontinuity. For a jump discontinuity, we have a jump discontinuity in a situation where our fx, you have got both solution for a limit of fx where x approaching an x value, which is a, from the left hand side, and a solution for a limit of fx where x approaches a from the right hand side. So when both limits of approaching from both sides exist but not equal to each other, then we have a type of discontinuity, and that type of discontinuity, we call it a jump discontinuity or non-removable discontinuity. For example, in this graph, if you check our fx is running, then it jumps here and starts running from another position. On removable discontinuity, it occurs when fx, when the limit of fx where x approaches a exists. When the limit of fx exists, it means the limit of fx approaching an x value from the left hand side is equal to the limit of fx approaching the x value from the right hand side. And the removable discontinuity, it only exists if the limit of fx is not equal to fa. So when these two values are not equal to each other, then you can say we have got a removable discontinuity. For example, in this graph, if you check the graph of our curve is running and we've got a removable discontinuity at x is equal to 3. This removable discontinuity is indicated by a small circle on our curve. Our third type of discontinuity is infinite discontinuity. We have got an infinite discontinuity if one or both of the solution of our limit of fx where x approaching a from the left hand side or a limit of fx where x approaches a from the right hand side, you have got a solution of plus or minus infinite. Then that type of discontinuity, we call it an infinite discontinuity. We have a discontinuity in our functions where we have got vertical asymptotes. So in a function, when we have got a vertical asymptote at a certain value of x, in that situation, we say we have got a discontinuity, infinite discontinuity. Because as you see in our graph here, our line either will run close to the line of asymptote without crossing it, it runs to infinity, goes down, or goes up, getting close to the line of asymptote without crossing it. Let's now look at some of the laws of limits which you apply when you're solving the limits. We have got, when we have got the limit of fx where x approaches a and the limit of gx when x approaches a exists, and we have got an n as an integer which is a constant. If you're applying a limit of laws on addition, if, for example, if we have got the limit of fx plus gx where x approaches a is the same as solving the limit of fx x approaches a and get the solution, then you add it with the limit of gx where x approaches a. So on the multiplication law, when you have got the fx times gx, the limit of fx times gx where x approaches a constant a is the same as solving the limit of fx where x approaches a and get the solution, and then you multiply with the limit of gx where x approaching a. So on division law, when we have got a limit of fx divided by gx where x approaches a is the same as solving the limit of fx where x approaches a and get the solution, and then you divide the solution with the limit of gx where x approaches a as a solution, where only when in the situation where the limit of gx is not equal to 0. So on a constant law, whenever you've got the limit of a constant, let's say the limit of 10, where x approaches a certain constant, a certain number, let's say a, always the solution of a limit of a constant is equal to a constant. So if you've got a limit of 10 where x approaches 1, the answer is still going to be 10. So the answer will return the constant of that limit. Let's look at some of the special laws for limits. So we have got the first law that's saying limit of x, whenever you've got the limit of x to the power n minus a to the power n over x minus a, where x approaches a, is always going to give you n a times n minus 1 for all real numbers of n, for all real numbers of n. So the second law is saying limit of sin theta over theta, where theta approaches 0, is always going to be 1. And the third law says limit of tan theta divided by theta, where theta approaches 0, is always going to be 1. And also limit of 1 minus cos theta divided by theta, where theta approaches 0, is 0. And the limit of cos theta, theta approaches 0, is 1. And the limit of exponent x, where x approaches 0, is always going to be 1. And the limit of exponent x minus 1, where x approaches theta, is going to be 1. And the limit of x plus 1 over x to the power x, where x approaches infinite, is equals to exponent to the power 1. Here are some exercises that you can test your understanding and your knowledge. Just work through all these exercises, trying to apply the limit laws. We have come to the end of our chapter 3 lecture for Mathematics 512. Thank you all for being part of Richfield Hybrid Learning Program. I wish to see you again in our next lecture for chapter 4.